Hey guys, alright, today what we're going to look at is parallel and perpendicular lines. So that's what notice you'll have a graph up on the board. So what I want you to do is take a minute. I will, well actually you pause the video, right? I can't pause the video. Pause the video and copy this down. So first thing you want to do is make a coordinate plane. I went by ones, but if you notice I put twos in here just so you knew that I went by ones, but it kind of might be a little confusing there. But really, it's just going by ones, so make a coordinate plane going by ones, and then you're going to make a line A, B, and C. Alright, so this is -4, 3, and 1, 2, so that's one particular line. This next line is -3, 0, 1, -1, so that's line B, -3, -4, and 2, -5 is line C. So go ahead and copy that down. Pause right now. Alright, welcome back from your pause. So hopefully you have your coordinate plane. It looks just like mine. Hopefully use the straight edge. Now what we're going to do is we're going to determine if these lines are parallel. And what you know from the definition from the beginning is parallel lines share a slope. So they have to have the same slope. Alright, so what we'll do is we'll do some work to try to figure that out. There's a couple ways to do that, but the first thing I'm going to do is I'm going to look at line A. I'm going to find the slope of line A. I'm going to find the slope of line B. And then I'm going to find the slope of line C. All I'm going to do is I'm going to use the slope formula. So that's really what I'm going to do. So I'm going to speed up the video because you guys should be good with finding the slope formula. So go ahead and do that with me using the slope formula. We're using line A, line B, and line C. Alright, now that you have that written down in your page, remember we're just finding the slope for each one of these. Remember this, I should have actually put m equals in here. M equals, m equals. And then we're just going to do the calculation to actually find the slope. So go ahead and do that now with me. I'm going to speed up the video a little bit, so if you need the pause, make sure you pause it. But I'm basically just finding the slope of line A, line B, and line C. Alright, now that you've done those calculations, so I have line A, line B, line C, I have the slopes of each one of those. You can see that we have -1/5, -1/4, and -1/5. So looking at this, we can determine that line A and line C are the parallel lines. And that's what they're asking us for. It's to determine which of the lines are parallel. And you would say line A and line C are parallel because they share the same slope. Now, if you have a graph, you don't have to use the slope formula. Remember, you could use the counting box method if you wanted to. So that's what we're trying to figure out. They have to have the same slope. So if you look at line A and C, these two lines right here, you can see that the distance between those two are equidistant, meaning the distance is the exact same. So that's all we're doing, guys. Parallel lines have the same slope, so you have to remember that. Put that into the memory banks. Parallel lines have the same slope. Alright, so in this example what they want us to do is they want us to write a line that goes through the point 5, -4, and it's parallel to that line. Alright, so it has to go through this point, but it has to be parallel to this line. So the thing that we need to remember is, what do we know about parallel lines? What do we talk about? Yeah, that's right. They have the same slope. So really all I have to do is look at the fact that this line that goes through that point has to have a slope of 2. So right there, that's all the information we need to figure out what the equation would be. So they give me a point and a slope. If they give me a point and a slope, what form do you think you would use? Exactly, we would use y minus y1 equals mx minus x sub 1. That is your point slope form. Alright, so that's what we're going to use. So all I have to do now is, we know that this is x sub 1, y sub 1. Y minus -4 equals 2x minus 5. Flip this guy, and we have y plus 4 equals 2x minus 5. So right there, pretty much we are done, right? Because it's just saying, doesn't tell us what form to put it into. If we wanted to solve it and put it into slope-intercept form, we could. There is another way you could do this as well, and maybe I might show you that as well. So you could basically find your y-intercept if you wanted to. You could do this. So you could technically, if you wanted to use slope-intercept form, I'll show you this. You could do y equals mx plus b, right? So we do know a couple things. I know a y value, I know the slope, I know the x value, and I don't know the b value, so that's what we're going to figure out. So for this, the b value would be negative 14, right? So really now I can just rewrite this, and hopefully this will show up on your screen. So y equals 2x minus 14. So whatever form you want to use, it really does not matter to me unless they state it. You could use point slope form. Sometimes they might say to state it. Some of you guys are probably super used to this because that's what you've used in the past. Or point slope form might be a little bit new for you guys, but to me it really doesn't matter which one you choose. I think the book shows you how to do it this way. I was taught this way, so just want to show you two different ways of doing it. These both mean the same, remember, because if you simplify this down, you would see that it would actually equal that one. Okay, so that's how you would basically write an equation when they give you a point and a line that we want it to be parallel to. So, all right, one more example. Actually, two more examples. All right, so the next thing we're going to take a look at, guys, is perpendicular lines. So what you need to know about a perpendicular line is if you have two lines and they intersect, you should see that they... Now, we don't necessarily know that this makes a 90-degree angle, but I know, and I'm going to tell you why I know in a minute, but they'll make a 90-degree angle. So when you guys get into geometry, you'll be dealing with degree measures a little bit more than we do in algebra, but that's a 90-degree angle, a right angle. So there's right angles all over the world. So even here, you guys can see that all these grids make up 90-degree angles, or the tile on your floor, or anything like that. Your book makes a 90-degree angle. They're all over the place. Now, what you need to know about perpendicular lines is, yes, they make 90-degree angles, but how do we know that they make 90-degree angles? Well, the telltale sign is the slopes, all right? So if the slopes are opposite reciprocals, all right, so just remember that, opposite reciprocal. Think about that. 1/2, what's the reciprocal of 1/2? You would know it would be 2 over 1. Now, those wouldn't be perpendicular because they have to be opposite. Well, what would be opposite 1/2? You would say negative. So opposite reciprocals, that's something that we need to know. Just make sure that you realize that you basically just flip the fraction and make it a negative. So if looking at these two, you can see that this guy is a negative and it's the reciprocal of 1/2, right? Because if you just flip it, what's really 1/2 of, what's really negative 2 divided by 1 is really just negative 2. So you can see that something like that. These two right here would be so opposite reciprocals of each other. And also note that the book, guys, uses negative as well. So you could say negative or opposite reciprocals. It does not matter to me. Just make sure that you know the difference. So maybe negative reciprocals might be easier to remember, but I like opposite because 1/2, positive, negative, those are opposite values. So whatever way works for you, just remember that it either has to be a negative reciprocal or an opposite reciprocal. All right, so in this example, what we're going to do is we're going to determine if these lines are parallel or perpendicular, or which lines are parallel and perpendicular, right? So we want to look at these, and basically the first step that you want to do is you want to put it into this form, okay? So that's all I'm going to do with this guy. Actually, I'll do it the work over here, so hopefully you can follow me over here. If I have x plus 4y equals 3, all I'm doing is taking my equation and I want to write it in slope-intercept form. Okay, so that was line B. That's that one, line B, line A. And I want to do the same exact thing for line C. So I'll kind of box this in so it doesn't get confused. That was all line A. And then this one over here will be line C. I'll try to stay out of my way a little bit. All right, so all we have to do is take this guy and solve it. Same exact thing we just did. Put it into slope-intercept form, because I'm going to show you in a minute why we're doing that. So divide everything by -8. Y equals, that simplifies down, right? 2 divided by -8 is really going to be -1/4 x. 16 divided by -8 is -2. All right, so once we have that done, so this was line C. Right, we're looking here, we're looking here, and then we're looking here. So a lot of places to look at. But what we want to do is we know that if something is parallel, they share the same slope, but they have different y-intercepts. So we want to make sure that they have different y-intercepts. So which ones share the same? So line B and C are the parallel lines because they share the same slope, right? So we know that they share the same slope and have different y-intercepts. So the next one we would actually look at and go, okay, which ones would be perpendicular? So actually line A will be perpendicular to line B and line C, because if you notice, look at the slopes right here, right here and here, opposite reciprocal, or negative reciprocal if you want to think of it that way. I always like opposite, but opposite reciprocals, right? So you can say line A. So easy way to write that, you can say line A is perpendicular. That's the perpendicular symbol that you see a lot in geometry, so you might as well get used to it now, to lines B and C. So make sure you note that, and you know it's right perpendicular, so you know that that's what that symbol means. But that's as easy as this is. You guys are real good with putting stuff into slope-intercept form. So we're just trying to figure out if they're parallel, they have the same slope. If they're perpendicular, they have opposite reciprocal slopes. Okay? And that's it. Remember, in parallel too, they have to have different y-intercepts, because what happens if they have the same y-intercept? Exactly, it'd be the same line. If they're the same line, then they wouldn't be parallel, they'd just be the same line. All right, last example, guys. So this one is very similar to what we did previously did in the start of this video. They want us to find a line that goes through negative 3, 1, but it's perpendicular now to this line right here. So what we have to think, all right, if it's perpendicular, I know it has to be an opposite reciprocal of this slope. What's the opposite reciprocal of 1/2? Flip it, right? So 1/2, if I flip it, it would be 2/1. If I make it opposite, it would be negative 2/1. I'm just going to call it negative 2 though, right? Might as well, right? Negative 2/1. It's just negative 2. All right, so now you can do it 2 different ways that we talked about. You can use point slope form, right? You can do it that way. You basically take your values and sub them in. And then this would be x minus negative 3, which really just be plus 3. So you could do it that way. It depends on if I tell you to put in slope-intercept form, you might have to solve this out a little bit more. Or you could use the other method, y equals mx plus b. Well, we know the y value, I know the slope, and I know the x value. So I could take this, or I am going to take it, and you're going to go 6, divide by 6, not divide, subtract, you get negative 5. So b equals negative 5. So technically, the way you would write this is y is equal to negative 2x minus 5. So either one would be okay. I might state too, if you need to do slope-intercept form, you would do it this way. But if they're just asking you to write an equation in a line that passes through the point, why not just leave it in point slope form? That has enough information if I wanted to graph this, just as much as that one does. So it all depends on what is stated. If they don't state it, go ahead and use point slope form, right? Let's be smart about it. That's all we're doing. So these are parallel and perpendicular lines. Remember, this is a video. Pause it, rewind it if you need to. Slow down. You don't have to rush through this. Take your time with these notes. I want to make sure that you guys understand this. So remember, parallel lines have the same slope, but different y-intercepts. Perpendicular lines have opposite reciprocal slopes. And it's okay if they have the same y-intercept. So just opposite, right? Opposite reciprocals. And that's it. So make sure that you take notes. Have any questions, please let me know. I'll see you in class.